So we are discussing about the HDFS concepts. In the last sessions, in the first session, we discussed about what is Hadoop, what is the background for Hadoop, and then in the yesterday session, we started with the Hadoop ecosystems, and then we started the HDFS, Hadoop Distributed File System. Okay, so the course content and everything will be given to you. Okay, everything will be uploaded in the Google Classroom. I will provide you the Google Classroom very soon. Okay, and then the Hadoop distributed file system, we are doing that. So in that, it is the cluster of different machines. Here the cluster of servers, all the machines are servers only. Okay, and if we have a file, the file will be divided into several blocks. Each block will be stored in different machine. So block 1 of size 64 MB, block 2 of size 64 MB, and so on. Here the block size 64 MB, it is in the old fashion, that is in the old versions, but in the new versions the block size is 128 MB. If you want, you can increase the block size to 256 MB also. That is depending upon your requirement and the data available. Okay, so another important point is these blocks will be replicated in the other machines also to provide the reliability. Okay, so the block 1 will be stored again in another machine, block 2 will be also stored in another machine. That is called how many times the blocks will be replicated. That number is called the replication factor. If the replication factor is 3, then each block will be stored 3 times in 3 different machines. That is the consideration. And then if the replication factor is 2, only 2 times it will be repeated. Replication factor is 15, then 15 times it will be replicated. So in this way, we have to choose which is the good one for our cluster and for our organization. We have to choose that. Okay, 3 is a good number for any cluster. Okay, and then here the file is stored in the form of the blocks. Which block belongs to which file? We don't know that concept. We don't know that information. So to maintain that information, we have to maintain a table. The table of the file name and corresponding block names where they are available. So we have to maintain a table that is like file 1, block 1, it is available in node 1, file 1, block 2, it is available in node 2, file 1, block 3 in node 5, file 2, block 1 is in node 2, file 2, block 2 is in node 3, file 2, block 3 is in node 7. In this way, we will maintain the list of the blocks and files, related files, and the location where it is available. So this is also called, actually in the regular operating systems terminology, it is called the FAT, file allocation table, and we can call this as the namespace also. We can call it as the namespace. Since we are calling this as the namespace, and this namespace can be dedicated, one machine will be dedicated to store this namespace, so that is called the name node. So all the machines, they have to communicate to the machine which is having the namespace for better communication, and that machine is called the name node. And all other machines, they are holding the blocks, that is the actual data. So because of that reason, those nodes are called the data nodes. Data nodes, name node. So these are the 2 types of nodes available. Okay, so this is about the overall architecture about the HDFS. Now I'm not going to discuss in detail about the name node and data nodes. Now I'm going to the next level. Here, let us say, for example, if one data node is failed, what will be happen? At any time one data node is failed, what will be happen? Nothing will happen, because the blocks are available in other machines also, other nodes also. Because of that reason, we need not worry about this. We need not worry about the failure of the data nodes. So even if one data node is failed, then the other blocks, other replications may be available in some other data nodes, so we can get the information very easily. Now we may get one doubt: if name node is failed, then we will lose the namespace, then the cluster is useless. So how can we maintain that? For that, we have the concept of backup node. Actually, in the old versions, there is a secondary name node, and then checkpoint node, and then backup node. In the different names, different servers are maintained to recover the name node. But nowadays, we are using the backup node only. Actually, in the recent version of Hadoop, the name nodes are maintaining, more than one name node is maintaining. Generally, two name nodes are maintaining. One is active, second one is the passive. Meaning that active name node, actually the name node is the active name node. The backup node, it will be the passive name node. That is called the passive name node. What it will do is, whenever there is the update in the name node, immediately that will be reflected in the passive name node also. There is a backup node. Okay, so backup node will be called also the passive name node. So whenever the name node is failed, immediately the passive name node will become as the name node, okay, active name node, and then we can reconfigure the name node, and we can up that. Then we can continue our services without any interruption. Okay, in the olden days, what happened, see, if the name node is failed, there is a secondary name node available, but it will not active immediately. We have to reconfigure the name node, and we have to recover the old data from the secondary name node, and then we have to start the name node. So it will take some time. So instead of that, backup node was initiated, and the active and passive name nodes are initiated, so that without any interruption, we are getting the data. We are getting the data, uninterrupted data. Give me a minute. Yeah. Any doubts here? Any doubts here? Hello. Are you able to understand? Okay. Yeah. 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 Tell me.
Hello, sir.
Yeah. Tell me.
So, like in our university, because I told you that day, bioinformatics deals with a lot of data. We have almost petabytes of data we are working with.
Yeah. Yeah. Yeah.
So we have these HPC clusters in which we have the SSH login.
Okay.
Is that same
HPC
as
means
this one? Huh?
HPC. What is the full form
High
of
power
HPC?
clustering. High power clustering.
High power clustering. Okay. High power clustering, that is also different concept, but that is also the distributed environment only.
Like we have to submit jobs in that. So there is a shell script in which there are some parameters, PBS, this one node, this much wall time, this much. Then
Yeah, that is different technology. This is Hadoop. Hadoop is replacing all these things.
okay, so what is the can you please tell me the in comparison so I understand what is
Yeah,
the Hadoop is comprising
yeah,
all these means in the sense.
okay. First, I have to see about the HPC first of all. Actually, I did not work on that. Okay,
Like
first
I
I
can
will
tell
see
you,
that.
in we are having three systems like Carbonate, Big Red, and Cast. These are the three. We
Okay,
we can get the login for three of them, but
okay,
our data, whatever I'm creating in one of them, like I will have a central SSH ID with my username for the university.
okay,
I can log into Cast, I can log into Big Red, I can log into Carbonate. But the
okay.
data that is there, it is centralized to three of them. I can log in from anywhere to access the data.
Yes, it is also the same concept, but internal architecture we have to see whether the entire data is storing in the central server or is it the distributed. That we have to see that in
Okay.
HPC.
Mm-hmm.
Okay, that I don't know
Okay.
what it is, which technology they are using. I don't know. I have to verify that and I have to tell you. Okay,
Okay.
so here the concept is the data is distributed, the processing is also distributed.
Okay.
Right? So
Okay.
here the technology, I will again explain what is the name node, internal architecture of the name node, what is the internal architecture of the data node, what is the starting procedure of the name node, what is the starting procedure of the data node also I will explain, but not now. First I
Okay.
want to take you into the environment. So
Terminology.
after
Yes.
that I will explain, after that I want to make you comfortable with other concepts.
Okay.
Do you understand what I am telling right now? I mean the concept.
That's what I'm trying to understand because I know about the HPC. Uh,
Uh,
so I
uh,
wanted to connect so that I understand
First,
what you're telling me.
yeah, first you confirm that whether it is a centralized server or distributed server.
Okay.
You ask your in your, you have to verify the architecture of the HPC.
Okay. I'll find out and
Okay,
let you know.
yeah, okay. If it is a centralized, it is completely different from here. If it
Okay.
is a distributed, it is a similar manner.
Okay.
Based on that, I will explain you.
Okay, sir. Thank you.
Okay, okay. Yeah, in the centralized server, it is a client server architecture. It is our regular Oracle server, like our regular Oracle server or web server. Okay, meaning that one server is down, then the entire data will be lost. Meaning that the entire data will be maintained in one machine only. Okay, the data storage, data processing, and everything will be maintained by one server, and all remaining machines are the clients. But here, all the machines are servers. All the machines are storing the data. All the machines are storing the data. Okay.
Okay.
Yeah.
So
Okay
if
then.
suppose I have ABC data, it is there in no 1, 2, 3, all the machines.
Yes. I will give you another clarity here. See here. Let us say, for example, I have one file. That file blocks are available in this machine, in this machine, and in this machine. Even if you have the file in, the data is in these three machines, you can still access the data without any interruption from this machine also, because they are interconnected. All
Exactly.
these are interconnected. So you will feel that we are working on the single machine. You will feel that you are working on the single machine, but it is distributed.
Right. This is what I
Got it?
was telling. Like we have three accounts, but we can access the data from any one of them.
Yes, that is the architecture. That is depending upon the architecture, which architecture
Okay.
they have used internally, that we have to
Understood.
observe.
Okay.
Okay, in centralized also we can make it possible.
Okay.
Okay, so we have to understand that. Okay, let us see. Okay, okay then. So this is about the base concept of the cluster. After that, Now cluster is available. Okay, all the machines within the cluster. Actually, I have shown you the links to the name node only, but there is the communication between these nodes. Each node is connected to each other node. This is fully connected network. Don't think that it is a centralized server. There is no centralized server concept. There is no centralized server concept here. So each node is connected to each other node. That you have to understand. Okay, don't think that it is a centralized like this. So each machine is connecting to other machines. So there is the internal communication with all, but the approval should be from name node. For any communication, the approval should be from the name node because the namespace is available in the name node. Right?
Yes, got it.
Okay. Now, okay. Anyway, we are in the cluster. All these machines are the part of the cluster. They can access the name node easily, and any machine can access any other machine easily. So there is no problem with the interaction. Now, outside world, if any outside client, if they want to communicate with the cluster, how can they communicate? That is here, that is the Hdfs client. Now let us see here, we have the cluster. We have the Hdfs cluster. Now I am the client outside the Hdfs. Now I want to communicate with the Hdfs. How can I communicate? That is, for communicating with Hdfs, the client should have the Hdfs file system interface. The client should have the Hdfs file system interface. What is this Hdfs file system interface? It is a way to communicate with the Hdfs. So the library, it is simply a library. It connects with Hdfs. So through Hdfs file system interface, the client can communicate with Hdfs. So that in the client means it is also a machine. If some file X is available in the client machine, that can be uploaded into Hdfs through Hdfs file system interface. So that, let us say for example, file X is available in the client, that can be uploaded into Hdfs cluster. X can be available here, so that we can upload into Hdfs because of this Hdfs file system interface. Got it?
Yes.
It
So
is an
the
interface. Yeah, tell me.
so the interface is also a software or something, or it's
Yes,
the
yes, it is a small software. It is a small
like
piece
we
of,
have these FileZilla and these types.
maybe. No, not FileZilla. For Hdfs, there is a configuration directory. For Hdfs, all the machines inside the Hdfs, they are having some configuration directory. Here, the Hdfs file system interface means it will also have some interface, some directory, configuration directory, which connects with the Hdfs cluster. Okay, it is not like FileZilla. Okay, if you have the Hdfs file system interface, then only you can communicate directly with the Hdfs by the client. Otherwise, what you have to do, you have to connect by using SSH. In client, we have the SSH, right? Secure shell.
Yes.
By using secure shell, you can connect with one of the node. You can connect with one of the node, and from this you can communicate with the cluster. That is another way.
Right.
Okay, instead of having this SSH, actually we should have so many permissions and others. Instead of that, if you install the Hdfs file system interface in the client machine, then you can directly access the Hdfs. All the files available in the Hdfs, they will be accessible through this client.
Okay.
Got my point?
Yes.
Yes. Now there is the user application. What is the user application? It is a small application developed on Hdfs or Hadoop. Okay, let me confirm other candidates are able to understand or not. Yes, are you able to understand, all of you? Others? Sunita is giving some responses. Others, I want to get the information from others. Are you getting? Yes, yes. Okay, good. Okay.
Sir, here one more
Now,
question I'm having.
uh,
Now, I don't know it is connected to this or not. Supposing, is this different from now? You see, these days we are having those AI platforms, right?
ah,
Supposing you have your data, you can work with remotely for a
yes,
company from your
yes,
home, right?
yes,
So
yes.
there are two types in that. Either the company will install something in your
Mission,
uh,
yes.
local machine such a way that you can access their
Data, yes,
functionalities to work with your data, or
yes,
you have their portal in which you have login ID and you will
yes,
put your data into their systems directly there.
yes, yes,
So is
yes.
that connected with this HDFC, HDFS?
HD, HDFS, it is a separate cluster. You can communicate with the HDFS cluster. You can upload the data into HDFS cluster, and you can download the data from HDFS cluster. And if you have the HDFS file system interface, and for all other clusters of Hadoop also, they have the interfaces. If you have the interface, you can have the direct interaction with that. It is like installing. You have given the first case. In the first case, they will install their software in our machine so that we can access their data and their functionality. It is same like that.
Okay.
If you are using SSH, through SSH, if you are communicating with the one of the cluster machine, then it is a second case, whatever you have told.
Oh.
Ah, okay, yeah. Rohit is asking one more doubt. HDFS interface connect to main node or a cluster? See, here all the nodes are servers only. So you can connect with any server, but you can, if you give a request to any server, that request will be sent to the name node only through any server. You can connect to here, yeah, you see this here. You can connect to this server, or you can connect to this server, or you can connect to this server. You can connect to any server. If you want to access the HDFS, you should have the permission from name node. That is the basic rule. You need not directly connect with the name node. That will be taken care by cluster. If you connect with any node of the cluster, that will communicate with the name node automatically. Got my point? And one more doubt, Raj is asking some doubt. Yeah, is HDFS connecting to main node? Yeah, that's what. Okay, okay. Unmute. Raj, you want to ask something? I will unmute you. 1 minute. Yeah, Raj, you can talk now.
Sir, tell me, as you are saying, see, HDFS is a type of system where data will be stored on each server, right?
Yes.
Now, my question is, suppose I am a client, okay,
Hmm.
I want to access the data. Let's say I am accessing node 1.
Hmm.
Okay, so node 1 is having the data which is available on other systems also, right?
Yes, because
Same.
it is a cluster. 1 minute. Okay. For that, I have to give one clarity here. See here. Here, this is the region of this node. This is the region of this node. Let us say, for example, okay, like this. This is the
Mhm.
region of this node, and this is the region of this node, like this, right? And what is the cluster? What is the HDFS cluster? The HDFS cluster is, yeah, I will change the color so that you will understand. I'm taking green. Yes. See, this is the HDFS cluster. See the green color. Now see. each machine is having its own file system as well as the HDFS file system also. There are two parts in each system region. Am I correct?
Sir, please explain again.
You see the green color box, green color boundary.
Okay.
The green color boundary is going through each machine's space. Am I correct?
Okay.
So if you take this machine, there are two parts. This is first part, this is the second part. Am I correct? If you take this machine, this is the first part, this green color region, this is the second part. In this is the first part, this is the second part. Am I correct? Are you getting? In this is the second part, this is the first part. First part is the local machine, local operating system for that particular node. Second part is the HDFS part. So it is providing some space for Hdfs cluster. Now if you communicate here, this is a client. If the client is communicating with this machine, then he is interacting with the local environment of this machine. Since this local environment is closely connected to the HDFS area, so you can easily access that area. Once if you enter into this area, this second area, this is the common for all, meaning that in this green color region, if you have a file X, in this green color region, you can access this X file from this node, from all the nodes, and also by using the client which is connected to this particular node. You can access from this client also because it is connected to one of the node which is participating in the cluster. You got my point?
Okay, little bit. I will go through it. Okay, sir. One more question I have. I missed 2-3 sessions before. Tell me, in order to install or doing installation, we need Linux environment, or I am having a Windows environment. So is this okay to work on Hadoop for Windows environment, or we need Linux?
What is your system configuration?
Windows 10,
RAM.
16 GB.
RAM. 16 GB. You need not worry. I will explain you how to install the machine, how to install Hadoop in your machine. Don't worry.
So that you will install on what, VirtualBox or on the direct system?
VirtualBox.
Okay, VirtualBox, right?
Yes.
Okay, so when we will do that?
After completion of this theory part. First we have to complete the theory part and then we have to enter into the practical level.
Okay, right.
Okay. Sir, I have one question here.
Yes.
You said these two are they like 1 and 2, right? 1 and 2 nodes, 1 and 2. For each node we have 2 machines, right?
Yes. Not 2 machines, 2 areas in the machine.
2 areas in the machine, and our we can connect our data to the first or the second.
Yes, first we will connect with the local area of the node. Through that we can communicate with the HDFS part, second part.
So the first one, the first one is the local area of the node, and second one is the HDFS.
Yes.
Okay.
Yes.
What is the difference of these two as compared to our local laptop? Suppose I am having my laptop, I am the client, I'm having the laptop here.
Yes.
And then if I connect to the local node and the HDFS node, what is the difference in that?
See, if you are connecting through SSH, you will connect to the local area, that is first part of the node. If you are using SSH. If you are using HDFS file system interface, you will directly access the second part.
Okay.
You will directly access the second part. You need not go for first part.
And what is the added advantage if we are getting to the second part directly?
The time will be saved because you need not communicate with the local part of the machine, and you need not go to that second part. You need not do all these things. Directly you have the direct access. For example, if you have a file X in your machine, if you are connecting with through SSH, first you have to copy your X into the local part of this machine. then you can upload into Hdfs. If you have the Hdfs file system interface, this X can be directly copied into the Hdfs.
Oh, got it.
Got my point?
So if you're using SSH, you'll have use that /// and you'll have all those, and then
That
get
I
into
will
it.
let you. That I will let you know.
Okay.
And then now
Actually, I'm working with HPC without having any knowledge. That's why I'm having so much confusion.
No problem. Don't compare with your HPC. This Hdfs architecture is different.
Okay.
Yeah. So see here, if you have the user application means, let us say for example, if we have our mobile application which is working on Hadoop. I am giving some more simple example. Facebook account. You have the Facebook account, right? The Facebook account website we are opening, right? Web page. That web page is the user application. That is connected to the client. That client is having the Hdfs interface. Your user application is connected to one of the client of Hadoop. Actually, that is the Facebook server for us. For us, for the user application, this may be server, this may be the web server, but it is the client for Hdfs. It is the client for Hdfs. So we are not using the Hdfs services directly. If you are posting some message in the Facebook, you are using Hdfs. Do you aware of that? Do you aware of that?
No.
You are using the Hdfs? No, because the client is hiding everything. The client of Hdfs is hiding everything. We don't know what is happening inside. Where it is storing the data, we don't know. Only we have the user application. So user application will not give you the information where it is storing and all. Just what to store. That's it. Okay. And let us say, for example, if you have the Hdfs file system interface here, whatever you have this, if this Hdfs file system interface is included in the user application, then it can directly interact with the Hdfs. You need not go through client. Got my point?
So here the client is Facebook, right?
Yes.
And we are the user application. Our user application is we. Okay.
Yes. Got it? So in this way, there are so many things are there, but only the thing is we are accessing the Hdfs cluster as the client and as the part of the data node. Okay, we will not communicate through application. Okay. Now, what is the Hdfs client? What the Hdfs client can do? The Hdfs client can write or it can read the data into Hdfs or from the Hdfs, meaning that it can write the data, it can read the data. The client can read the data from the Hdfs and it can write the data into Hdfs. So these two operations are allowed for client. That is also with the permission of name node, right? And then another point is it is a single writer multiple reader model. What is this single writer multiple reader? All are single writer multiple readers only. One user will write, number of users can read. Am I correct? One user will write in any regular servers also. If you upload your data set, the data set can be used by some others also, if you give the permission. Am I correct? Are you getting?
So you are saying single writer multiple reader model. So is this system work on multi-threaded environment, just like multi-threaded environment? Multi-threaded. We have a multi-threading environment.
Yes. In the multi-threaded environment, multiple readers are allowed. That is correct.
Right.
That is
But
allowed.
only one time we can go for the writing. One thread is allowed to write and the rest of the thread is allowed to read only.
Yes. Then how it is different from other single writer multiple reader? Here the meaning is different. Single writer multiple reader means once if you write, once if you write the data onto HDFS, you cannot modify it.
Okay, means completely immutable.
Yes, it is immutable.
Okay. Mm-hmm.
Meaning that once if you write the data, it is read only. Multiple readers can read it, but nobody can write, nobody can update. If you
Means
want, you can.
if I am a, suppose, sir, I can understand in this way. If I am a client, with the help of HDFS file system interface, if suppose I am uploading an image on one of the cluster node, okay, you are also a client, then you can view my image, but you can't perform any operation on the image, right?
No, yes, we cannot perform. I cannot perform any operation on that.
But you can view that.
Yes, if you have permission. If I have the permission, then only I can view that. In that also there are a number of users.
Then how it is related to Facebook? We in Facebook, what happens? Whatever we are doing, anybody can view, right? Anybody can display. Anybody can click on the like, or anybody can go for the comments. Anybody is writing on our whatever the text or images we are uploading there.
You can. That's what I am continuing. You can add the data. You can add the data to existing data, but you cannot modify the existing data. Anyone can add the comment, but they cannot update our comment. Am I correct?
Okay, right.
Right. That is the point.
So that is
that
called
clear?
single writer, multiple reader model.
Yes. Single writer, multiple reader. Single writer, multiple reader. Right. So this is the HDFS client concept. I hope you understand. Right.
Right.
So how is the concept? Is it boring? Theory, completely theory.
It's not boring, but it really takes a lot of the brain to understand it.
Yes, I'm unmuting all. Yeah. You can share your experience and your feeling about this concept.
Because
Is
you
it
are
boring
allowing
or?
us to exchange our thoughts and ask whatever whenever we have doubts. I think initially for some time we will be confused till we actually get into the path, and then I think we'll be on track. That's what I feel about myself.
Yes.
Sir, one more thing, one more question from me. In order to understand this Hadoop, how much of programming we should know?
Which programming you know?
I know Java well.
Then it is enough.
CoreJava,
Hadoop is
Advanced Java, I am comfortable.
More than enough.
It is enough.
Okay.
So, Balram, are we going to start the classes from tomorrow?
Yes, this is also the class. This is also the architecture. I'm explaining about the architecture, right?
Okay.
I'm not stopping the class. I'm continuing. I'm not repeating. You can observe. I'm not repeating the class.
You're right. It's very different from yesterday. I understand. I just shared the payment confirmation to Durga Soft.
That's okay. That's different case that you can talk with those people. Here about my class, I'm not repeating any concept. I'm just revising and continue to the next concept.
It is good. It is good.
Yeah, Balram, I have one query.
Uh,
Yeah, you are saying backup node, right? So backup node is real-time synchronization with name node.
yes.
Okay, so whatever the operation, whatever the operations performing in the name node, it will sync with the backup node as well, right?
Immediately.
Okay.
And actually, in the latest version, the multiple name nodes are allowed. Already I told you that active name node and passive name node. Okay, backup node is called the passive name node right now in the latest versions. So what happened, in the olden days, in the old versions of the Hadoop, periodically the backup node will be updated in the old versions. But right now, every operation immediately it is updating in the backup node. Immediate.
Okay, Balram. So if that backup node is acts as name node, so another backup node will create immediately?
No. That backup node will become as the active name node immediately. Meanwhile, anyway the hardware engineers will be there. The cluster managers will be there. the cluster managers, they will again up the name node and they have to synchronize again with the backup node.
Okay, fine.
Right? Actually, this is in the admin part, but even though I want to explain this.
Okay, fine.
Okay, nobody gave the answer for my question.
Sir, please ask again.
No. Are you feeling that it is a boring concept because of the
That's
theory?
okay. No. Theory is important one. We need to understand architecture first, and it's a really important one.
No. Actually, the commercial way of dealing this subject is first we will start with the commands and then think about the architecture.
Right.
Commands you can learn within one day. It is not a big deal.
So it's better that we can do installation and parallelly then we can go for what the small introduction and architecture part also.
No. Once if we start the execution part, we will not get the interest on architecture part. Anyway, it is executing. Whatever I am giving the command, if you type that on the environment and it will be executed, so it is okay. What is there inside, we don't need to understand. So that type of
my one more question I have.
yes.
Generally, I have checked for the jobs when we are going for Hadoop job, they are asking that Hadoop with big data. If big data itself is a Hadoop, right? Or Hadoop itself is big data, then why we are saying big data in Hadoop?
No. There are number of tools for big data, not only Hadoop. Okay. Hadoop is one environment, one framework. Hadoop is a framework. Hadoop is a framework for handling big data. One of the framework.
And what any other framework?
Blobseer. Blobseer is there. Blobseer is another one, and so many have developed. You can search in the internet. You will find so many big data tools. Hadoop is the main concept. Okay.
If someone asks me a question, what is big data? Big data means huge data, huge amount of data, or data stored in cloud or something like that.
That I explained in the first session. For what are the characteristics for the big data? Volume, variety, velocity, and value. That I explained in the first session and second session. Please go through the recorded videos. Okay. For handling that big data, one of the framework is Hadoop.
Okay. So let's take an example of ICICI Bank. ICICI Bank has 100 of branches, right? Okay. Daily they are getting crores of transactions. So are these transactions are storing on their local computer or they are using a cloud environment?
Cloud environment only, because they are centralized in, they are the global, right? Global environment. You can access your account from anywhere.
It means they have one centralized server, let's say in India or anywhere other in Mumbai.
Yeah, I don't know how ICICI is following. I don't know. I heard that Yes Bank has started the distributed environment.
Okay, distributed environment means they are having all their machines are treated as servers, not nodes.
Yes. Server. No, actually, in Hadoop concept, all the servers are considered as nodes. We will call them as nodes.
But all them are servers. They are not client nodes.
Yeah. No, they are not clients. They are the servers only. All of them are servers only.
And each server is connected with a name node.
Yes. All the nodes are connected. All the nodes are connected each other. It is a fully connected network.
So data will be stored in whatever the data we have. Let's say today in Mumbai, let's say 1 crore transactions have been done in Yes Bank. So that all 1 crore transactions will be available where? On one node, say 2 node, or on all the nodes which are connected in the cluster.
Yes, all the nodes can access the same transaction.
No. Accessing is fine. But where on which node actually the data is going to be stored?
Yes, that is depending upon not in name node. Name node will have only the metadata. That is the name
IP addresses.
Balram, I said any node, not any node.
Yeah, okay. A namespace, and the data may be available in any one of these nodes that is not accessible for the end user. Where the data exactly stored, that is not accessible to the end user. Right?
But where we can suppose my question is suppose I am working in Yes Bank, 10 computers are there. I am doing some transaction. My transaction is going to be stored where? If we are working in a cluster, means my transaction is not going to be stored in my computer, right?
It is not in your computer. It is connected to the cluster. If it is connected to the cluster, in one of the data node, the data will be stored.
One of the data node.
Yes. In which data node it is stored, we don't know. That is available with the name node. You cannot directly access the block also.
Okay, let me go through the session again. So then I will ask you tomorrow then. Okay.
Yes, that is better. That is better.
But good, lot of good questions today.
Yes. That is correct. Yeah. Any more questions?
Hi Balram, this is Rohit. I joined the session today. So I want to understand that what is the course content actually about the ecosystem? What are you going to follow on the ecosystem?
You first go through the previous two videos, previous two sessions. Ask
Where
them
can
to send the ask the institute people to send the link for previous session. In that I have explained clearly what topics I'm going to cover.
I think they already sent it today. If you have registered, or else just ask them, send me the link. It's a YouTube link. It's a YouTube link.
They send me one link they sent, but it is not there actually.
Oh, it is not
You
there?
ask them. You ask them that they will provide. You need not worry.
Oh, okay.
Yeah.
Okay.
In the last two sessions, I explained what topics I'm going to discuss, right?
Last session I didn't attend actually. So,
yeah, that's what. And you just go through the recorded session. Still, if you have doubts, let us discuss. We have so much of time for discussion. Yeah, I don't have any problems to discuss.
So in the ecosystem, like for analytics purpose and streaming purposes, so are you doing with heap or peak or scala or anything?
Yes. I'm going to cover yes. I'm going to cover. That's what I explained in the previous sessions. I'm going to cover HDFS, MapReduce. MapReduce only introduction part and one program. Okay, and then pig, hive, scoop, flume.
Okay.
Pig, hive, scoop, flume. Pig, hive, they are for the analytics, and scoop and flume for the data ingestion. Scoop is for connecting with the databases. Flume is for the streaming data. Okay, and apart from them, I am going to cover the hue, how to use the hue concept, hue environment to use all these applications. And in the last session, I will give you the brief description about the OOSI. What is OOSI? How to schedule the programs. That I will explain in the last session.
So I think Durga has sent Hadoop developer course document. Yeah, Balram. That's the name of the document. Yeah.
Okay.
Sir, can we have any reading material so that we can go through before the session?
No, before the session I will not provide anything. After the session only I will provide the so much of material and textbooks also. I will provide you the textbooks for each and every concept.
Okay.
You can go through them. There are a lot of examples available. You can go through them and you can execute them directly.
And the virtual box that we are going to use, what do we have in virtual box? Windows OS or Linux OS?
Linux.
Linux OS,
Actually,
right?
It is not Linux. It is the CentOS. Don't install anything right now. I will let you know what to install.
Okay, fine.
Only you have to make it ready 8 GB of RAM minimum 8 GB of RAM in your machines. That is only the requirement.
Okay. That's fine to me, right?
Okay. Any more doubts? Okay, I think we can conclude the session for today. We can meet tomorrow, and I will explain some more concepts in the Hadoop HDFS architecture. And then I think from day after tomorrow onwards, we can start the practical sessions also.
Okay, fine, it's fine. Fine.
Okay, thank you.
So, Balaram,
Yeah,
9 p.m. again you will meet, right? I showed my interest on the DS data science actually. So,
yeah, 9 o'clock. Yes, 9 o'clock. That is the data science is on 9 o'clock. Yes.
okay, thank you.
Yeah, for newcomers, how is the session? Is it okay for you?
Yeah, session is good, but yeah, it's good, no problem, right?
Yeah.
Sir, are you taking data science also?
Yes.
What you are covering in data science?
The data science, data science is the combination of big data and machine learning. In the data science, I am covering the machine learning part. In the machine learning part, I am covering the linear regression, logistic regression, ANN, artificial neural networks, CNN, RNN. That is the
So
image analysis, image classification.
Are you covering artificial intelligence also?
No, artificial intelligence, machine learning is some part of the artificial intelligence. I'm not going to cover artificial intelligence.
Okay,
if we cover all the things, see, listen, if we cover all those things, it will become the university course. It will take 1 year.
So how much is the duration for data science?
6 weeks.
And the language, if you are going for these algorithms, we are going to do practically also these algorithms?
Practical, definitely.
Using what? What language you are using for practical?
Python.
Python only, or you can go for R also?
No, only Python. I'm not going with R because again another confusion will be there, the syntaxes and all.
Okay.
I'm taking you to Python.
Which libraries you are confirming actually? Which are the main libraries you are doing? Python.
NumPy, Pandas, Scikit-learn, TensorFlow, and Keras.
Oh, okay, sure.
Matplotlib.
And Matplotlib
Okay.
also.
Okay. If you have any doubts, you can join in that session and we can discuss.
So today is the first session for data science?
Data science also third session. Same Hadoop and data science we have started on the same day. Demos only.
Okay. I think we'll go for Hadoop first, and later on in future we can go for data science.
Okay, fine, no problem.
6 weeks means it will be 2 months or 1.5 months, like that.
1.5 months. Actually 6 weeks, but it may take 7 weeks. We don't know because you have to understand. Students has to understand, right? Otherwise,
correct.
there is no use.
Correct. Yeah.
Based on the student pace, I have to change my speed. Okay, then. Thank you for listening. Okay, you can give the feedback out there. Okay, thank you.
Okay.